Hello, future lawyers, and welcome to the Mathemagical series. Today, we are going to learn mathematical concepts related with time and work. Now, these kind of concepts are normally a bit difficult to understand, but once you grasp these basic concepts, I am sure you will be able to do all the questions that CLAT throws at you in form of caselets. CLAT has already asked a caselet related to time and work in previous years. This time around also it is expected that it might ask. Once you have understood these basic concepts that we are going to discuss today, I am sure you will be able to do all the questions, any caselet, any question that has been thrown by CLAT at you. So just understand these basic concepts and then solving those questions will become very easy. Because time and work questions are very easy. Also, the calculations that are involved in solving these questions are also quite easy. So if you have a better understanding or a good understanding of these basic concepts, probably you will be able to solve those caselets within minutes. Hence, it is a very scoring caselet if it comes on time and work. Hence, it is a very scoring topic to learn. So do understand these basic concepts. So let's start by understanding the mathematical concepts related with time and work. So our today's session will be divided into 8 parts. We'll start from the basic formula right till the conceptual caselets. If you are clear with some of the other concepts, you can move directly to the different concepts that are there in the class. So there are different timestamps provided to you, so you can make the most of your time and speed or move directly to the sections where you feel you need something to understand. Okay, so let's start with the first. So first is the basic formula, where work is known as efficiency into time. Efficiency is nothing but speed at which a person can do certain work. Okay, so efficiency is nothing but the speed at which a person can do certain work. That is known as efficiency, and time is basically the time taken by that person to do that particular work. So if you multiply efficiency with time, you will get the total amount of work that is done by the person. Similarly, if you take time on the left hand side, this becomes efficiency is equal to work upon time. Similarly, if you take efficiency on the left hand side, it becomes time is equal to work upon efficiency. So if you see this formula, you will find it relevant to the formula of time, speed and distance. So distance is equal to speed into time. So this formula is quite similar to time, speed and distance formula, which is distance is speed into time. Here instead of distance we have work, and instead of speed we have efficiency, which is nothing but speed of doing a certain work. Okay. So let's try to solve some problems to understand this formula even more clearly. A man can fill a bottle in 6 minutes. So for one man, efficiency given to us is 1 bottle per 6 minutes. So 1 bottle per 6 minutes. This is the efficiency that is given of one man. How many men should be employed to fill 1845 bottles from 11 AM to 12:30 PM? Okay, so time given to us is 90 minutes. So time is 90 minutes. Now for one man, if we see, efficiency is 1 bottle per 6 minutes, time is 90 minutes. So work done by one man in 90 minutes will be efficiency into time. So that will come out to be 1 by 6 into 90. So that will come out to be 15 bottle per 90 minutes. So this is the work that is being completed. That is 15 bottles will be completed by one man in 90 minutes. Now overall work that is given to us that required to be completed, it is of 1845 bottles. Okay, time again is 90 minutes. We need to find the number of men required. So what we will do is, let number of men be n. Okay. So efficiency of these n mans will be, efficiency of one man is 1 bottle per 6 minutes, or rather we can say that one man can finish the work in 15, can finish the work of 15 bottles in 90 minutes. Simply we are given that work is 1845. So how many mans are required? So efficiency of that man will be n times the efficiency of one man, that is 6 minutes. So n upon 6 bottles per minute. Okay. So from that again we know that work is efficiency into time. So it becomes n by 6 into time taken is 90 is equal to total work, that is 1845. So from this if you calculate, n will be equal to 123. Hence number of mans required will be 123. Now this was one of the ways with which you can do this question. Okay, this was the first method. The second method was, since we have already calculated the work done by one man in 90 minutes, so work done by one man in 90 minutes is 15 bottles. Okay. Now the amount of work done required is 1845 bottles. So number of men required will be, number of men required to fill 1845 bottles will be 1845 divided by 15. Okay. So that will be equal to again 123 men. Okay. So this is the second method with which you could have done this question. This is the second method, wherein in this second method we have only used the unitary method, while in first method we have used the formula of work is efficiency into time. So you can proceed any which way you find it suitable for you. Both these methods are correct. You can proceed accordingly. Okay. Next, question number 2. Each student in a school can make 5 handicraft articles per day. Again, efficiency of one student is given to us, that is they can make 5 handicrafts per day. So 5 handicrafts per day is the efficiency of one student. If in an exhibition 1125 articles are exhibited, then find how many days were taken by 25 students to make these articles. So this was the efficiency of one student. So efficiency of 25 students will be 25 into 5 handicrafts per day. So that will come out to be 125 handicrafts per day. So this is the efficiency of 25 students. Now work given to us is 1125 articles, okay, or handicrafts. So that is 1125. We need to find the time. So time will be simple. Time is nothing but work upon efficiency. So that will be equal to work is 1125 divided by 125. So if you do the calculation, 25 5s are, 25 4s are, and 5s are, so it will be 5 9s are. So answer will come out to be D, 9 days. Okay. Here we use the formula time is equal to work upon efficiency. Third question, a man can stitch a bag in 10 minutes. Okay. Again, efficiency of one man is given to us. It is one bag per 10 minutes. So it is one bag per 10 minutes. Okay. So that is nothing but 1 by 10 bag per minute. Okay. How many such men should be employed to stitch 1, 2, 4, 5 bags if they work from 10 a.m. to 12:30 p.m.? Now time is given to us, it is 2 hours and 30 minutes. So we will convert that into minutes because our efficiency is given to us in minutes. So 2 hours 30 minutes would mean 150 minutes. So we are given time, we are given efficiency of 1 person. Let the number of men required be n. So efficiency of n mans will be n by 10 per minute. Total work is given to us. Total work given to us is of 1245 bags. 1245 bags. We need to find the number of man required. We know the time. So again we will use the formula of work is efficiency into time. Work given to us is 1245. Efficiency of n man is n upon 10 into time given to us is 150. So simply if you calculate this, it will come out, n will come out to be 83. So our answer will be D. 83 men will be required. Okay. Again we have used the simple formula of work is efficiency into time. Next mathematical concept that we are going to learn about is direct and inverse relation. So work is directly proportional to efficiency and time. That means work is efficiency into time. If efficiency is constant, this would mean that work is proportional to time, directly proportional. That is, for more amount of time if you do the work, the number of work units will also increase. Okay, given the efficiency is constant. Similarly, if time is constant, okay, if this value is constant, then this will imply that work is proportional to efficiency. That means you are doing the work for a given amount of time, but if you increase the speed of your time, you will be able to do more work in the given time. So work is directly proportional to efficiency when time is constant, and work is directly proportional to time when efficiency is constant. Similarly, efficiency is directly proportional to work, okay, and it is inversely proportional to time. Now this is again a very important concept given that work is constant. So when work is constant, that is when we are doing the same work, efficiency will be inversely proportional to time. If you take more time, your efficiency will be reduced. If you take less time, your efficiency will be increased. Similarly, with respect to time, we can again say time is directly proportional to work and time is inversely proportional to efficiency when work is constant. Again here, work needs to be constant, and over here, efficiency needs to be constant. Similarly, over here, again, time needs to be constant. Okay. So these are very important relation. Just by looking at that, you might feel that it's quite easy to understand, but its applications are the one that are very important. Make sure you are able to utilize this relation in the questions as well. Let's see how to utilize these relations in the questions. Working efficiencies of P and Q for completing a piece of work are in the ratio of 3:4. That is efficiencies of P upon efficiency of Q. The ratio given to us is 3:4. So this is 3/4. We need to find number of days to be taken by them to complete the work will be in the ratio. So we need to find the ratio of time. Now here we are talking about the same work. That means work is constant. Now when work is constant, we know that efficiency is inversely proportional to time. That means if the ratio of efficiency is 3:4, the ratio of their time will be the inverse of this. Okay, so inverse of this would mean time taken by P upon time taken by Q will be the inverse. So inverse of 3/4 is 4/3. So answer will be 4/3. That is C. Now this is a very important concept. It has numerous application. Make sure you have understood this concept. Okay. Let's move on to next question. A's 2 days work is equal to B's 3 days work. Okay. If A can complete the work in 8 days, then to complete the work B will take. Okay. So here we are given the relation that A's 2 days work. Okay. So amount of work that can be done by A in 2 days is equal to B's 3 days work. Okay. So basically we are given the ratio of their efficiencies. So, or let's say the ratio of their times are given to us. So time taken by A and time taken by B, it is in the ratio of 2/3. Now both are doing the same work, that is work is constant. So this means efficiency, we all know it is inversely proportional to time. This means the ratio of their efficiency will be the inverse of the ratio of their times. So this will imply that efficiency of A upon efficiency of B is equal to 3/2. Now if A can complete the work in 8 days, then to complete the work B will take, or in this question we even don't need to calculate their efficiencies. We can directly say that if A takes A upon B, the ratio is given to us, that is 2/3. Now it is given that to complete the work A is taking 8 days. So how much time will B take? So ratio is 2:3 and time taken by A is given to us. So we don't need to calculate the efficiency for this particular question. So you can simply remove this efficiency part over here. Okay. So simply the time taken by A is given to us, which is 8 days. So that is 8. This is the time taken by A. So time taken by B we need to find out, and the ratio is 2:3. So this will imply time taken by B will be equal to 12 days. Okay. Here we were clearly given the ratio of their times. We were given the time taken by A. So simply put that value and you can calculate the time taken by B. You don't need to calculate the efficiency for this particular question. So answer will be B, 12 days. Next, to complete a piece of work, A takes 50% more time than B. If together they take 18 days to complete the work, how much time will B take to do it? Okay. Now time taken by A is equal to 50% more time than B. That means it is taking 150% of time taken by B. So this implied time taken by A upon time taken by B. The ratio is 150 upon 100, or that is equal to 3/2. So this is the ratio of their time taken by A and taken by B. Now it is given if together they take 18 days to complete the work, how much time will B take to do it? Okay. Whenever such question comes, there is an important trick to do that. We are given the total time. Now we know that work is inversely proportional to time. Okay. So total work is given to us. That means 1 upon time taken by A plus 1 upon time taken by B. Its value is given to us. That is 18 days. So this value is given to us. This is a very important relation to understand. This is very important. Time taken by A plus time taken by B, that is 1 upon time taken by A plus 1 upon time taken by B is equal to 1/18, because work is inversely proportional to time. Hence, this relation is very important to understand. Okay, this is a very important magical concept that will help you in many questions related with time and work. Now we know that time taken by A and time taken by B is in the ratio of 3/2. Okay, we need to find the time taken by B. Okay, simply what you can do is you can assume that time taken by A is equal to 3x and time taken by B is equal to 2x. Simply put that value over here. So you will get the value as 1 upon time taken by A, that is 3x, plus 1 upon time taken by B, that is 2x, is equal to 1/18. Simply take the LCM. So 5x upon 6x square is equal to 1/18. So 6, this will be 3. So this will imply that the value of x is equal to 15, because this x and this will get cancelled. So the value of x is 15. Now we need to find the time taken by B. So time taken by B was 2x. So that would mean 2 into 15. So answer will be 30 days. So answer will come out to be 30 days. It's a very simple relation, yet it is very effective in solving many questions. Also, this will save a lot of time of yours, which we'll see in the further class as well. Okay. So let's move on to another magical concept related with time and work, and that is the chain rule. In the chain rule, if M1 man can complete the work W1 by working T1 hours per day in D1 days, and similarly if M2 man can do the amount of work W2 by taking T2 hours and working D2 days, then M1 D1 into T1 upon W1 is equal to M2 D2 T2 upon W2. This relation is nothing but work is efficiency into time. So this, we all know that work is equal to efficiency into time. So here what we have basically done is we have calculated the value of 1. So 1 will be efficiency into time upon work. Okay. Now this is nothing but efficiency. Okay. M1 doing the work for T1. Okay. So this is nothing but the efficiency, and they are doing it for D1. So this is the time for which they are doing. So this is nothing but efficiency into time divided by work. So basically we are equating this value of 1 to get this formula. Okay. So this is how this formula is being derived. That is, we are basically equating the value of 1. Like for example, this can be written as E1 T1 upon W1. Similarly for W2, it will be E2 into T2. So this will again mean the value of 1 is E2 into T2 upon W2. Okay. So E1 T1 upon W1, E2 T2 upon W2. Both the values are 1. So we have equated both the values, and from that we have got this relation. Okay. Similarly, if efficiency of M1 man is E1 and efficiency of M2 man is E2. So again this part will become the efficiency part and this part will become the time part. So this is again nothing but efficiency into time upon work. Similarly over here, this is again efficiency and this is again time. So this is T2, this is E2, this is T1, E1, W1 and W2. So this is a very basic formula, yet very effective in solving many questions. Let's see how to use this formula in the questions. If 3 men or 6 women can do a piece of work in 16 days. Okay. So time is 16 days. 3 men or 6 women, they can do a piece of work. That means work is same and time is also same. So work W1 is W1 only, or let's say it is W2. the work W1 is W, time T1 is 16 days, number of men is 3. Okay. Similarly over here, number of men, so let's say m is equal to 3. Similarly W2 is again W, time T2 is again 16 days, and here instead of men the M2, that is equal to 6 women. Okay, here it was 3 men. So we'll again use the chain formula, which is nothing but M1 into T1 upon W1 is equal to M2 into T2 upon W2. So from this we get 3 men into T1, that is 16 days, divided by W1, that is W, is equal to M2, now that is equal to 6 women, into T2, that is 16, divided by W. So W will get cancelled out, 16 will get cancelled out. This would simply mean that 3 men are equivalent to 6 women, or 1 man is equivalent to 2 women. Okay. Or if you want, so you can take days as well. So 16 days. So this will become 3 man days is equal to 6 women days, or 1 man day is equal to 2 women day, because this is 16 days. Okay. So this becomes man days, and 3 man days is equal to 6 women days. So 1 man day is equal to 2 women day, or 1 man is equivalent to 2 women. Anything you can say about it. Okay, that is, the work done by 1 man in 1 day is equivalent to 2 women doing the same work in 1 day, or 1 man can do twice the work done by women in a single day. This is the basic interpretation of this value. Now in the question it is asked, how many days can 18 men and 8 women do the same piece of work? Again, the work remains the same. Okay, so let's say this is W3, the work remains the same. Number of men that are given over here, that is M3. So number of men is 12 men plus 8 women. Okay, and we have already known that 1 man is equivalent to 2 women, or 2 women is equivalent to 1 man. So this means 8 women will be equal to 4 men. So this will become 12 men plus 4 men. So this will be 16 M. This will be your M3. Okay, we need to find T3. Again, we'll use the same formula. So M1 into T1 upon W1 is equal to M3 into T3 upon W3. Now we know the values of M1, T1, W1, M3 and W3. We can find the value of T3 from that. So M1 is nothing but 3M, that is 3 months, into time 16 days, divided by work is W. M3, that is equal to 16M into T3. We need to find work is again the same. So work and work will get cancel. Okay, 16 and 16 will get cancel, M will get cancel. This means T3 is equal to 3 days. So the answer will come out to be B, 3 days. So we have used the chain formula twice to solve this question. First, to get the value of 1 man day, that is how much men are equivalent to women. So first we have established that relation, then we have used this relation, and again used the chain rule to identify the number of time taken, or number of days taken to complete the work. Next, again 4 men or 6 women can do a piece of work in 12 days, working 7 hours a day. Now from this question you could have easily understood that when we are talking about the same work and same time, we don't need to use this formula. We can simply say that 4 men are equivalent to 6 women. Okay. So by using, we are essentially using the same formula, but by now you should understand that even without using the formula, you should be able to derive this thing, that 4 men are equivalent to 6 women directly. Why? Because the work is same and time is also same. Hence 4 men will be equivalent to 6 women. Next, how many days will it take to complete a work twice as large? So let's say W1 was W. Now here given that our work is twice as large, so this means it will be 2 times W, 10 men and 3 women. Okay, so M2, okay, it is 10 men and 3 women. So from this we can say the value of 3 women will be equal to 2 men. Simply take the 2 common. So 2 men are equivalent to 3 women. So simply put this value over here. So this becomes 10 men plus 2 men. So that will be equal to 12 M. So this is your M2. Okay. And they are working 8 hours a day. Okay. So T2 is equal to 8 hours per day. We need to find the number of days taken. This is the question. Now for W1 we have assumed the work as W. M1 was 4 months. Time they were working was 7 hours per day. Number of days they have taken are 12 days. Okay. Again using the same formula from chain rule, that is M1 D1 T1 upon W1 is equal to M2 D2 T2 upon W2. Okay. So M1 D1 T1 will simply put the values. M1 is 4, D1 is 12 and T1 is 7. Work 1 is W. It is equal to M2. M2 is equal to 12 into days. We need to find out D2 into time 8 hours divided by the work. The work is 2 times W. Okay. So simply solve this equation. This will get cancelled out. 12 will get cancelled out. This becomes 4 and this 4 will get cancelled out. So D2 will be 7 days. This will be the answer. So our answer will be B, 7 days. Okay. So simply we have used again the formula from the chain rule, equated the equations, and we have got the answer as 7 days. Now we are going to learn some short tricks. Okay. The one we have already tried before in solving a question. So we'll see how that trick came by. Okay. So the short trick is that if A can do a piece of work alone in X days and B can do the same work in Y days alone, then A and B both can do the same work in XY upon X plus Y days. Okay. This is the simple formula, that if you are given that if A can do a certain piece of work in X days, B can do the same work alone in Y days, then the time taken by both of them, it will be XY upon X plus Y days. Now how does this come? Simply let us assume that the work is W. Okay. Work is W. Now if A is taking X days, for B also work is W only, so time taken by B, it is Y. Okay, so the total time taken by them will be nothing but the efficiency. So efficiency of A will be equal to work upon time. So that will be equal to work upon time taken by A is X. So it will be W by X. Similarly, efficiency of B will be W upon Y. Now if both are working, so at that time also total work is W. Both are working, that means efficiency will be efficiency of A plus efficiency of B. So that will be equal to W upon X plus W upon Y. This will be the efficiency. So time will be work upon efficiency. So that will be equal to W upon X plus W upon Y. Okay. So if you solve this, you will get it as XY upon X plus Y. This will be the total time taken. Okay. So total time taken will be XY upon X plus Y. That is how we got this formula. So this is just for your understanding that how we got this formula. Even if you remember this formula, it's well and good. One more thing to remember is total time is nothing but individual time addition. So it will be 1 by X plus 1 upon Y. This will be equal to total time. So again, if you solve this, you will get this as X plus Y upon XY is equal to 1 upon total time. So total time will be XY upon X plus Y. So from both these method we get the same answer. You can use either of these methods to understand how we came up with this solution. Personally, this is the easiest method to understand. Okay, this is also easy. It becomes a bit complicated because you have to calculate the efficiency and then the time. Here, from directly by knowing the relation that work is inversely proportional to time, we can simply calculate this equation. Okay, now we'll try to solve some problem based on this short trick. A can do a piece of work in 6 days and B in 9 days. That means value of X is 6, value of Y is equal to 9. How many days will both take together to complete the work? So time taken by both is nothing but XY upon X plus Y. So that will be equal to 6 into 9 upon 15. Okay. So this will be 18 by 5, so that is equal to 3.6 days. Simply by knowing this formula, we can calculate the answer of this question within seconds. So this is the magical formula. This is a magical trick. Do remember it. It will save lot of time in your CLAT exams, because in CLAT every second is very important. Next, a sum of money is sufficient to pay A's wages for 21 days and B's wages for 28 days. The same money is sufficient to pay the wages of both for how many days? That is simply the value of X given to us is 21. Value of Y given to us is 28. Again, we need to find the total time. Okay, so total time, because wages will be nothing but proportional to the time taken by them to complete the work. Hence, the total time taken by them will be 21 into 28 upon 21 plus 28. So that is equal to 21 into 28 divided by 49. So 7 3s are, 7 7s are, again 7 4s are. So it will be 12 days. Okay. Again, it was a very basic question. It's just that the language was a bit twisted in this question, where many students face lot of challenges. So whenever such questions comes related to wages or something like that, make sure that you are able to understand that what exactly is given and what is asked from you. Okay. Next, one man and one woman together can complete a piece of work in 8 days. A man alone can complete the work in 10 days. That is, let's say the value of x is given to us as 10 and both the value of total time is given to us. The total time is 8 days. Okay. We are asked in how many days one woman can do. That is, we need to find the value of y. Now we have simply run this, that 1 upon x plus 1 upon y is equal to 1 upon t. Value of x is 10, that is 1 by 10 plus 1 upon y, it is equal to 1 by 8. Now if we solve this, 1 upon y will be equal to 1 by 8 minus 1 by 10. So this implies 1 upon y will be equal to 10 minus 8 is 2, 2 upon 10 into 8. So that will be equal to, y will be equal to 40 days. So this will be the value of y. Okay. Simply knowing this relation, which we also use to derive the formula, we got this answer. You can do it like this. Okay. Also you can do it simply by knowing the formula, that is xy upon x plus y is equal to 8. We already know the value of x. So from that you can calculate the value of y. So you can do it in that manner as well. So it will be nothing but 10y upon 10 plus y is equal to 8. So that will be again 80 plus 2y equals to 10y. Sorry, 8y. So this will become 2y equals to 80 and y will come out to be again 40 days. Okay. So you can proceed with either of these methods. Okay. This was method 1 and this was method 2, directly using the formula. So you can proceed with any of these methods. Okay. So whichever method suits you, make sure you use that method. But using these tricks, using this mathematical tricks, you will get the answer within fraction of seconds. Next, A and B can do a piece of work in 12 days, B and C in 15 days, and C and A in 20 days. They will together complete the work in. Now we are asked that in how much time, if all of them work together, they will be able to complete the work. Now the information that is given to us is that 1 upon A plus 1 upon B, that is A and B can together do the work in 12 days. So that is equal to 1 by 12. Okay. Similarly, we are given B and C. So 1 upon B plus 1 upon C is equal to 1 upon 15. And 1 upon A plus 1 upon C, this value is given to us as 20. Okay. So these are the relations given to us. Now if all of them are working together, so let's just add all this equation 1, 2 and 3. So we add 1 plus 2 plus 3. So by adding all of this, you will get 2 times 1 by A plus 1 by B plus 1 by C. This is equal to 1 by 12 plus 1 by 15 plus 1 by 20. Simply taking their LCM, it will come out to be 60. So it will become 5 plus 4 plus 3. So that will come out to be 1 by 5. Okay. So that means if twice the number of people, okay, or you can simply take this 2 over here. So this will become 5 into 2. So this implies 1 upon A plus 1 upon B plus 1 upon C is equal to 1 by 10. That means A, B and C together will complete the work in 10 days. Okay. Simply knowing this relation will help you solve lot of questions. So these tricks are very important. Okay. Not just knowing the formula, but how we got that formula can also help you solve many questions. These are magical tricks. This will really work like a magic whenever you see such questions. Normally, students are afraid of such questions, but once you know the trick, especially this magical trick, these questions will be easy piece of cake. Okay. Next. Now we have already discussed the basic concepts. Now we are going to discuss concepts related with wages. Next, we are going to learn the concept, the problems related with wages. Now, simple thing to remember with wages is that wages will be directly proportional to efficiency or the amount of work done. As in, the person who is doing more work will be get paid more. But if they are doing the same work, then the person who has done more work, that is simply the person who is more efficient, will do the more work. Hence, we can say that the wages will be directly proportional to their efficiency or the amount of work done. Okay. So let's try to solve this problem. A and B, they can complete a piece of work in 15 days and 10 days respectively. They contracted to complete the work for 30,000. The share of A in the contract money. So the total contract was of 30,000. Now time taken by A is 15 days and time taken by B. So this time taken by B is 10 days. This ratio is 3/2. Now we have learned that when work is constant, efficiencies will be inversely proportional. Hence, efficiency of A upon efficiency of B will be the inverse of this, that is 2:3. And as we have discussed earlier, that wages will be paid in the ratio of their efficiencies. Hence, it will become 2/3. So we'll distribute this 30,000 in the ratio of 2:3. And we need to find the share of A. So share of A will become 12,000. So answer will be C, 12,000. Next. Two men undertook to do a job in 1400 rupees. Okay, they have taken an amount that is 1400 rupees. In 1400 rupees, they will complete the entire work. One of them can do it alone in 7 days. Okay, so let's say that A can do the work in 7 days. And the other, let's say B. So B can do the work in 8 days. Now with the assistance of a boy, they together completed the work in 3 days. So with the assistance of boy, C, we don't know in how much days, so let's call it C days. So when they all work together, that is A plus B plus C, when they all work together, the work got completed in 3 days. We need to find how much money will the boy get. In such questions, one important trick, which is going to be a magical trick that we need to follow, is that whenever such question comes, the easiest method to do such questions is that assume the work, that is the total work, as the LCM of the given number of time. Okay, so basically the work will be equal to the LCM of the times, that is 7, 8 and 3. So LCM of 7, 8 and 3. So LCM of 7, 8 and 3, it will come out to be 168. So we will assume that work is 168 units. Why we have done that? So that we can calculate the efficiencies of A, B and C. Once we know the efficiency, we will know how to distribute the amount 1400 amongst them. That's why firstly we have assumed work as the LCM of the time given to us. This is a very important technique to do, and trust me, this will work as a magic if you have learned this concept. Hence it is very important, the LCM method. Whenever times are given to us, simply calculate their LCM and assume that as the work. Okay, so work is 168 units. That means efficiency of A will be 168, that is work upon time. So time is 7. So efficiency will be 24 units per day. Similarly, efficiency of B, it will be equal to again work upon time, that is 8 days. So it will come out to be 21 units per day. Okay. Now we know the total work and total time. So the total time is 3 days. That means net effective efficiency is total work, that is 168, upon total time, that is 3 days. So that will come out to be 56. Now effective efficiency, when all are working together, the effective efficiency will be equal to efficiency of A plus B plus C. So this will come out to be 56 is equal to efficiency of A 24 plus 21 plus efficiency of C. So efficiency of C will come out to be 11. Hence the ratio of efficiencies of A, B and C, that is efficiency of A is to efficiency of B is to efficiency of C, it will be equal to 24 is to 21 is to 11. Hence this amount will get distributed in A, B and C in this respective ratio. So if you calculate this amount for C, that is amount by C received, it will be equal to 11 upon the total, that is 56, into the amount is 1400. Okay. So if you calculate this, 8 sevens are again 25. So this will come out to be 275 rupees. Okay, so answer will be B. So normally when such question comes, using this magical concept of taking out the LCM of the given tenure or the given time period, it will really help you speed up your calculation and solve the questions within fraction of seconds. So this is a very important trick. Do remember to use this trick in the questions if such kind of questions come in the exam. Next, A, B and C completed a work costing 1800. A worked for 6 days, B worked for 4 days and C worked for 9 days. So A has worked for 6 days, B has done the work for 4 days and C has done the work for 9 days. If their daily wages are in the ratio of 5:6:4, that is their daily wages ratio is given to us. We need to find how much amount will be received by A. Now amount of work done by A is for 6 days. Okay. For B is 4 days and for C it is 9 days. Okay, and their daily wages are in the ratio of 5:6:4. That is the total amount received by them. Amount received by A will be equal to the amount of work done, that is 6 days, and the daily wages, that is 5. Okay. Similarly, amount for B will be amount of work done, that is for 4 days, and his daily wages are in the ratio of 6, so it will be 6. Amount for C will be in the ratio of work done is for 9 days into the ratio is 4. So that will come out to be 30. This will be 24 and this will be 36. So this will be the ratio of their daily wages. Okay. So this is the amount, sorry, not the ratio of their daily wages. The daily wages ratio were given to us. Daily wages means per day payment. So their per day payment ratio was given to us. Number of days they have worked was given to us. Hence the amount received will be in the ratios of number of days worked into per day amount. So this is the total amount they will receive. So this is the ratio, that is amount received by A to amount received by B to amount received by C will be in the ratio of 30:24:36. So that will be, you can take 6 common, so it will become 5:4:6. So this will be their ratio of the amount received. Total amount is 1800. We need to find the amount received by A. So total amount is 1800. So amount received by A will be equal to 5 divided by 15 into the amount, that is 1800. So this will be 12, 120. So this will come out to be 600. So answer will be B, 600. Okay. Again, this was again a very basic question. We were given daily wages, that is amount per day, and we were given the number of days they were working. Simply if you multiply them, you will get the ratio in which their amounts will be distributed. So we got that ratio as 5:4:6. From that we got the amount received by A. Next, A, B, C, they are employed to do a piece of work for 575 rupees. Okay. A and C are supposed to finish 9/23 of the work together. So A and C together will finish 9/23 of the work. So what amount shall be paid to B? That means work done by B. So work done by B will be equal to 1 minus 19/23. That is equal to 4/23. This is the work done by B. Hence the amount paid to B will also be 4/23 of the total amount. So amount paid to B will be equal to work done by B into the total amount for the contract, that is 575. Okay. So simply if you do that, you will get this value as, so this will come out to be 100. So our answer will be A, rupees 100. Okay. Again, it was very simple. As we have already discussed, wages are always in the ratio of the amount of work done. So amount of work done by B was 4/23 of the total work done, and the total amount for the work was 575. Hence the amount received by B will be 4/23 of 575. That will be equal to 100 rupees. Okay. Now we will see some conceptual problems related with pipes and cisterns. Now remember the important trick that we have discussed earlier in this question, that is the LCM trick. This trick, this mathematical trick will be very much required in solving the pipes, in the questions related with pipes and cisterns. Let's try to solve the questions. A pipe can fill a tank with water in 3 hours. Due to leakage in bottom, it takes 7/2 hours to fill it. Okay. Now earlier, that is earlier when there was no leakage, the time taken was 3 hours. Now time with leakage is 7/2 hours. So this is 7/2 hours. In what time the leak will empty the fully filled tank? We need to find that in how much time the leak is going to empty the tank. As we have discussed the LCM method, we are given 2 times. So in such questions, we neglect this denominator. Okay. We will only take the LCM of 3 and 7. So capacity of tank will be nothing but LCM of 3 and 7. We neglect the denominator value while taking the LCM. So LCM of 3 and 7 will be 21. So we'll assume the capacity of the tank as 21 liter. This is the magical trick, that you need to take the LCM of these values. Once you have done that, the question becomes very easy to apprehend. Now the capacity is 21 liter. Time taken earlier by pipe. Okay. So time taken earlier was 3 hours. that means the efficiency of pipe is, this is capacity. Capacity is nothing but work. So work upon time. So that is 21 upon 3. So that will be 7 liter per hour. This is the efficiency of pipe. Next, again the capacity is 21 liters. Now this time the capacity, the total time with leakage was 7/2 hours. So total effective efficiency will be equal to 21 divided by 7/2. So that will be equal to 6 liter per hour. Okay. And effective efficiency is nothing but, this value of E is nothing but efficiency of pipe plus the efficiency of leakage. So this total is 6. Efficiency of pipe is 7. So efficiency of leakage we can calculate. So efficiency of leakage will be -1 liter per hour. Okay. We are getting here minus sign because the leakage is used to empty the tank. Okay. So pipe is used to fill the tank while leakage is used to empty the tank. That's why we get the minus sign over here. Okay. Now we know the efficiency of the leakage. That is, leakage is going to empty the tank with the speed of 1 liter per hour. Again, capacity of the tank is 21 liter. Efficiency of leakage is 1 liter per hour. So time taken will be capacity upon efficiency. So that will be equal to 21 hours. Okay. So our answer will be D, 21 hours. So you see, just by using this simple technique of taking the LCMs, our problem statement has become very easy. So this is a magical trick that you must follow, especially when you are solving any questions related with pipes and cisterns. Okay. Next, two pipes A and B can separately fill a cistern in 60 minutes and 75 minutes. So time taken by A is 60 minutes. Time taken by B is equal to 75 minutes. There is a third pipe in the bottom of the cistern to empty it. If all the three pipes are simultaneously opened, then the cistern is full in 50 minutes. So total time is 50 minutes. Okay. In how much time the third pipe alone can empty the cistern? Again, here we are introducing a third pipe which is used to empty the tank. Like in previous question, there was a leakage which was emptying the tank. Here, instead of leakage, we have a third pipe C which is used to empty the tank. Okay. Again, we are given these times. So we will again use the magical concept. We'll take the capacity of the tank as LCM of 60, 75 and 50. Okay. So if you find the LCM of this, the LCM of this will come out to be 300. So we will assume that the capacity is 300 liters. So capacity will come out to be 300 liters. Now for pipe A, the efficiency of A will be equal to the capacity upon time taken by A. So that is equal to 300 divided by time taken by A is 60. So that will come out to be 5 liter per minute. Similarly, efficiency of B will be capacity again, that is 300 divided by time taken by B, that is 75. So that will come out to be 4 liter per minute. Again, the total time we know, that means the effective efficiency will be total work, that is 300. The total time taken is 50. So the effective efficiency is 6 liter per minute. Okay. So this E is equal to efficiency of A plus efficiency of B plus efficiency of pipe C. Now this implies that 6 is equal to efficiency of A 5 plus efficiency of B 4 plus efficiency of C. Hence efficiency of C will be minus 3 liter per minute. Okay. Again, we'll be getting the minus sign simply because pipe C is used to empty the tank. Again, the capacity is 300 liter. We are using the pipe C whose efficiency is 3 liter per minute. Hence, time taken by C to empty the tank will be 300 upon 3. So that will be equal to 100 minute. So our answer will be C, 100 minute. So again, if you see, we have again used this magical concept of taking the LCMs. Once you do that, the problem statement becomes quite easy, and simply you need to use the formula of work is efficiency into time. In case of pipes and system, the work is replaced by capacity of the tank. Okay. Next question. A tap takes 36 hours extra to fill a tank due to a leakage equivalent to half of its inflow. We need to find the tap can fill the tank. We need to find the time in which the tap can fill the tank. Okay. Now we are given, let's say that there was a leakage which was equivalent to half of the inflow. So let's say the efficiency of the tap is equal to X liter per hour. Okay. And the efficiency of the leakage is equal to, leakage is equivalent to half of its inflow. So it will be X by 2 liter per hour. Okay. Let us assume that the capacity, so capacity of the tank, let it be C liters only. This time we don't need to take it in the terms of value. Even if we take it in terms of variable, we'll be able to solve it. Okay. If capacity of the tank is C liters, this simply means that the time taken by the tap will be, time taken by tap will be the capacity upon efficiency of the tap. So that is equal to C upon the efficiency of the tap, that is X. Similarly, time taken by leakage, due to leakage you can say. So time taken due to leakage, or let's say instead of calculating the time taken for the leakage, let's just calculate we are given the time taken by tap, that is C by X. Now the total time taken will be C upon the net efficiency of tank plus leakage. So that will be equal to C upon X plus X by 2. So that will be equal to C upon 2C upon 3X. So this is the total time, and this is the time taken by tap alone. Now we are given the difference between that. A tap takes 36 hours extra. This means T minus time taken by tap is equal to 36. So simply putting these values, we get C upon X minus 2C upon 3X is equal to 36. So if you solve this, you will get the value of X. So value of X will come out to be, this will become 1 upon 3x square is equal to so this is 36 hours. Okay. So C we have assumed. So C by X, 1C upon 3x square, it will be equal to, sorry, not X square, this will be X only. So this will come out to be C upon 3x is equal to 36. So C will be equal to 36 into 3x. Okay. So this will be the capacity of the tank in terms of X. We need to find the tap can fill the tank in how many hours. So time, that is, this is equal to C upon X. So this is equal to C value is 36 into 3x upon x. So this x and this x will get cancelled out. So this will become 36 into 3. So this will come out to be 108 hours. Now let's solve question number 3. A tap takes 36 hours extra to fill a tank due to leakage, which is equivalent to half of its inflow. So let us assume the inflow of the pipe, okay, or inflow of the tap, that is nothing but its efficiency be x liter per hour. So efficiency of the leakage, since it is a leakage, its efficiency will be negative and it will be minus x by 2 liter per hour. Okay. Now efficiency of the tap is x liter per hour. Let us assume the capacity of the tank be c liter per hour. So time taken by tap alone to fill the tank will be c upon the efficiency of tank. So that is equal to c upon the efficiency of tank is x liter. And the total time taken when the leakage is also there, the time taken will be c upon efficiency of tap, okay, plus the efficiency of leakage. So that will be equal to c upon efficiency of tap is x minus the efficiency of the leakage, that is x by 2. So this will become 2c upon x. Now in the question we are given the time difference, that is we are given a tap takes 36 hours extra to fill a tank. Okay, so the difference between the time is given to us when both are operating and when alone tap was operating. So this difference is given to us as 36. This means 2c upon x minus c upon x is equal to 36. So c upon x is equal to 36. Okay, and this is nothing but the time taken by tap alone to fill the tank. Hence our answer will be 36 hours. Okay. So again in this question we don't need to do anything, simply assume the capacity of the tank. We have already assumed the efficiency, we were given the relation between the two, and from that we could calculate these values. Okay. Next, a tank can be filled by two pipes in 20 minutes and 30 minutes respectively. Okay. So there are two pipes. Let's say pipe A whose timing is 20 minutes and another pipe B whose timing is 30 minutes. Now when the tank was empty, the two pipes were opened. After some time the first pipe was stopped and the tank was filled in 18 minutes. We need to find after how much time of the start was the first pipe stopped. Okay. Before we do that, the first thing we will do is we will use the magical concept. We are given two times. With that we'll find the capacity of the tank, which will be nothing but LCM of 20 and 30. So LCM of 20 and 30 will be nothing but 60. So we will assume the capacity as 60 liters. Okay. This is the magical concept that we have been using, and you must get accustomed by it now. Okay. So using this magical concept, we have got the capacity of the tank as 60 liters. Now it is given that they both were operating for the same time. Okay. We don't know for how much time were they operating. So we assume that time as t. When both are operating, the effective efficiency. Okay. Let's first find the efficiency of A. So efficiency of A will be C upon time taken by A. So that will be equal to 60 upon 20. So that will be 3 liter per minute. Similarly, efficiency of B will be C upon time taken by B. So that will be equal to 60 upon time taken by B is 30. So that will be equal to 2 liter per minute. Okay. Now we have the efficiency of A and we have the efficiency of B. Now when they both are operating, the effective efficiency will be efficiency of A plus efficiency of B, so that will be equal to 5 liter per minute. Okay. Now we are given according to the question that when the tank was empty, the two pipes were opened. Okay, both the pipes were opened, but after some time, the first pipe was stopped. That is, pipe A was stopped. The first pipe is the pipe which is filling the tank in 20 minutes. That is pipe A according to us. Okay, so we don't know and we need to find that time. So we assume that that time for which they both were operating was time t. Hence the capacity filled in that time will be efficiency, since they both were working, into time t. So this will be equal to 5 times t. So this is the capacity that will be filled in time t, that we don't know. And after that it was stopped and the tank was filled in 18 minutes. Okay, total time in which the tank was filled was 15 minutes. So after that, that is for the remaining time, that is 18 minus t, the capacity filled will be efficiency of B, because pipe A was stopped. So efficiency of B into 18 minus t. So that will be equal to efficiency of B is 2. So 2 into 80 minus t. Okay. This is the capacity and this is the capacity. Now we both know that the capacity of the tank is 60 liters. This means capacity filled till time t plus capacity filled till time 18 minus t. It should be equal to 60. So putting these values, we get 5t plus 2 times 18 minus t is equal to 60. So this will become 3t. This will be 36. So this will become 60 minus 36. So that will come out to be 24. So t will come out to be 8 hours. Sorry, 8 minutes. Not hours, 8 minutes. Everything is in minutes. Our answer will also be in minutes. Hence the answer will be D, 8 minutes. Okay. Now that we have covered the basic concepts of time and work, we have learned the tricks, the LCM trick, the trick of using the formulas, how we've derived the formula when A is able to complete the work in X hours and B is able to complete the work in Y hours, then what will be the total amount of time taken when both are working. So we have learned the basic concepts. Now it's time to utilize those concepts through caselets. So let us try to solve the first caselet. So in the first caselet, the data is given in the tabular form. We are given inlet pipes, which are A, B, C, D, and outlet pipes, which are P, Q, R, S. Inlet pipes means they are used to fill the tank, and outlet pipe means they are used to empty the tank. So we are given the respective times. Now first thing that we do when we are given the times is that we find their LCM. We use the magical trick and we find the LCM of all the times that is given to us, and that LCM will be the capacity of the tank. So capacity of the tank will be nothing but LCM of 20, 18, 24, 30, 36, 40 and 30. Okay. So we need to find their LCM. So if you do that, their LCM will come out to be 360. Hence the capacity will be 360 liters. Okay. This will be our capacity. Once you have the capacity, you know the individual timings. We can calculate the efficiencies of A, B, C and D using the formula, such as efficiency of A will be nothing but capacity upon time taken by A, and similarly for B, C, D, P, Q, R, S we can use the same formula and calculate the efficiencies. So once you do that, you will get these efficiencies of all of them. Okay. Now that we have the efficiencies of all the pipes, we know the capacity. Capacity is 360 liters. Now we can solve the questions. So the first question is, to fill the tank, tap C and D, they are opened at the same time. Okay. After 10 minutes, tap D is closed and the tap S is opened. how much time will it require to completely fill the tank after that? Okay. So firstly, C and D are open. When C and D are open, their efficiencies are 15 and 12. So that is their effective efficiency of C plus D. It will be equal to 15 plus 12. That will be equal to 27 liters per minute. Okay. After 10 minutes. Okay. So in 10 minutes, the amount of tank filled will be, so the capacity filled by C and D after 10 minutes will be 27 into 10. That is equal to 270 liters. Okay. Now after some time, after 10 minutes, sorry, tap D is closed. Now tap D is closed and the tap S is opened. Now S is used as a outlet pipe, hence his efficiency will be negative. Okay. How much time will it require to completely fill the tank after that? Now the remaining capacity. So remaining capacity will be nothing but total capacity minus the capacity filled by C and D. So that will be equal to, total capacity we have already assumed as 360. So 360 minus the capacity filled, that is 270. So that will be equal to 90 liters. So this is the capacity that is remaining now to be filled. Now to fill this capacity, the effective efficiency we have is C minus S. Okay. So C efficiency is 15 minus the efficiency of S, that is 12. So that is equal to 3 liter per minute. So we have C, we have efficiency. So time required will be capacity, remaining capacity upon the effective efficiency of C minus S. So that will be equal to 90 upon 3. So that will be equal to 30 minutes. So time required will be 30 minutes. Okay. So it becomes very easy once you have calculated all the efficiencies. Then simply you need to put the logic that is given in the question. Just read the question, understand the problem, and then everything is very logical. Hence, in the starting I mentioned that the problems related with work, time and work, they are based on logic, simply if you have understood the concept. So once you have understood the concept, once you have used the magical tricks, then simply all you need to do is use the basic logic. Next question. All the taps are open for 5 minutes and after that tap B and C are closed, and same time tap R is opened for emptying the tank. The amount of time taken to fill the tank, it is asked. Okay. So for 5 minutes, all the taps are opened for 5 minutes. So if all the tanks are opened for 5 minutes, the effective efficiency will be nothing but addition of all these efficiencies minus all these efficiencies, because they will be acting as an outlet. Okay. Okay, I think according to the question, it means that all the taps are open for 5 minutes means all the inlet tanks are open for 5 minutes. Okay. So 18, 20, 15 and 12. So it will become 38 plus 27. So that will be 65. 38 plus 27. It will be 65 liters per minute. So effective efficiency will be efficiency of A plus B plus C plus D. That comes out to be 65. Time it is opened is 5 minutes. So capacity filled by A plus B plus C plus D will be 65 into 5, that is 325 liters. Okay. After that tap B and C are closed. B and C are closed and same time tap R is opened. So now the efficiency will be A plus D minus R. So that will be equal to A plus D is 18 plus 12 minus the capacity of efficiency of R, that is 9. So 30 minus 9, that will be 21 liter per minute. Okay, this is the effective efficiency. Now amount of time taken to fill the tank, for that we need to find the difference. So the difference, that is the capacity remaining to be filled, will be total capacity minus capacity filled by A, B, C and D. So that is equal to 360 minus 325. So that will come out to be 35 liters. So this is the remaining capacity and this is the effective efficiency. So time will come out to be CR upon the efficiency, that is A plus D minus R. So that will be 35 by 21. So that will be 5 by 3. Okay. So answer will be 5 by 3 or 35 by 21. It is the same thing. So answer will be A, 35 by 21 minutes. Only thing was that all the taps are open for 5 minutes meant that all the inlet pipes, okay. They are open for 5 minutes, okay. So from that we have calculated this. Again in this question we have to simply use the logic. We have already calculated the efficiency and the total capacity of the tank. Next, due to choking of mud in pipe A and B, their efficiency decreased by 50%. The tank, if the tank needs to be empty by pipe Q and R, which is completely filled by A and B, the difference in the time taken for filling and emptying the tank is, okay. This simply means that A and B are used to fill the tank, but A and B efficiency is reduced to half. That means it becomes 9 and it becomes 10. So efficiency of A plus B is equal to 10 plus 9, that is 19 liter per minute. Okay. Capacity they are filling is 360 liters. So time taken by A and B to fill the tank will be capacity upon the efficiency. So that will be equal to 360 upon 19. So this is the time taken by A and B. Similarly Q and R. So efficiencies of Q and R, they are also 19. So efficiency of Q plus R, which is used to empty the tank, it is also 19 liter per minute. Capacity is 360 liter again. Okay. So the time taken will also be same by Q and R. That means the difference between the time will be 0 minutes, because A and B are also filling the tank with the same efficiency as the Q and R are emptying the tank. Hence time taken will be the same. So difference will be 0 minutes. Last question of the passage. The ratio of combined time taken to fill the tank to combined time taken to empty the tank. Okay. So ratio to fill the tank completely, that means inlet pipes are used, and to empty the tank, that means outlet pipe are used. Okay. So simply the ratio is nothing but the inverse of their efficiencies, because the capacity is same, and we have learned that when capacity is same or work is same, then time is inversely proportional to efficiency. So simply we find the ratio of their efficiencies, total efficiencies, and do the reverse to get the ratio between their time taken. So if you add all of this, you get the value as 38 plus 27, 65. If you add all of this together, again you will get 22, 31, 43. So ratio of their efficiency is 65 by 43. Hence the ratio of their times, inlet time to outlet time, will be equal to 43 upon 65. Okay. So answer will be A, 43 upon 65. Simply we have used the relation that we have understood earlier, the direct and inverse relations between the two. Next, now we'll do another caselet. Among 4 persons A, B, C and D, each does same work W with different efficiencies. They are doing the same work but with different efficiencies. A's efficiency is 25% less than C's efficiency. B's efficiency is 25% more than C's efficiency. And efficiency of D is 100 more than efficiency of A. And efficiency of C is 100 unit per hour. So we are given the relation between the efficiencies and we are also given the efficiency of C as 100 units per hour. So first thing we will do is, using this relation, we'll find the efficiencies of A, B, C and D. So C is already given. We can calculate for A, it is 25% less. So efficiency of A will be 75. Efficiency of B, it is 25% more, so it will be 125. Efficiency of D is 100 more than efficiency of A, so it will be 175, and efficiency of C is given 100 unit per hour. Okay, so we have calculated the efficiencies of all of them. Next, A and B work together only for 10 hours on a given day. What percentage of work was completed? Okay, A and B, they are working together, they are working only for 10 hours. We need to find the amount of work remaining. Now, as in the case of time, when we were given the time, we will take the LCM of those time to calculate the total work. Similarly, in case of efficiency also we'll do the same. To calculate the total work, we'll simply do the LCM of all these four quantities. So LCM of 75, 125, 100 and 175. So this is nothing but 25 into 3. This is 25 into 5. This is 25 into 4. And this is 25 into 7. So their LCM will come out to be 25 into 7 into 4 into 3 into 5. Okay, so this will be the total work. Okay, we need to find that if A and B work together only for 10 hours. So if A and B are working together, their efficiency will be A plus B, that is 75 plus 125, that is 200 unit per hour. Okay, the time they are working is 10 hours. Hence, work done by A and B will be equal to 200 into 10. So that is equal to 2000. Now it is asked that what percentage of work was completed. So that means percentage of work completed. Percentage work completed. So that is equal to work done by A and B divided by total amount of work into 100. So that will be equal to 2000 divided by total work, that is 25 into 3 into 4 into 5 into 7 whole into 100 to find the percentage. Okay, so 25 fours are, that is 100, 5 fours are, so 4 upon 21, it comes out to be 4 upon 21 into 100. So this is approximately 4 by 20. So approximate answer will be 20%. This can be written as 4 by 20, that will be 1 by 5. 1 by 5 into 100. So approximate answer will be 20%. Okay. Next, if A, B, C and D all started working together to complete the work, but D left after 2 days, find the time taken to complete the remaining work, assuming 1 day working hours are 10 for all the persons. Okay, we are given 1 day working hours as 10 hours. Now if they all started together, that means efficiency of A, B, C and D, it will be equal to addition of all this. So this will be 200, 300, 475 units per hour. Okay, D left after 2 days. So time, that is time is 20 hours for which they have worked in 2 days. 1 day they are working for 10 hours. So in 2 days they will be working 20 hours. Hence the work done by A plus B plus C plus D will be equal to 475 into 20 units. Find the time taken to complete the remaining work. Now for the remaining work, D is not present. That means A plus B plus C are remaining. So A plus B plus C will be minus 175. So that will be 300 unit per hour. Time we don't know. Remaining work. So work remaining is equal to total work minus work done by A plus B plus C plus D. Okay. So we know the total work is nothing but 25 into 3 into 4 into 5 into 7 minus 475 into 20. Okay. So simply if you do it, it will again, you can break this down, you can divide this by 25. So this will become 25 ones are 25 and 7s are. So 25 into 7 into 17 into 20. So you can take 5, 4, 20. So 25 and 20 can be taken common. It will be taken common. This will become 21 minus remaining will be 17. So this will become 4. So this becomes 2000. Okay. This will be 4. So this is 100. So this will become 2000. So remaining work is 2000. Efficiency is 300. So time required to do the remaining work will be the work remaining, that is 2000, divided by the efficiencies, that is 300. So this will become 20 by 3. So 20 by 3 is nothing but the answer should be, okay, to complete the remaining work, find the time taken to complete the remaining work. So remaining work is nothing but 2000. Let me just check my calculation. From 25, if we do 25 ones we left with, okay, here I've made the error. Okay, it will be 225. So this will be 19. Okay, 21 minus 19 will be 2. So 502. So this will come out to be 1000. Okay, so remaining work is 1000, not 2000. So it will be 10 by 3. So answer will be 3.33 hours. Sorry, my bad. I made a mistake, calculation mistake over here. 17 instead of 17, it should be 19. So the total work will be 1000. So 1000 by 300. So that will be 3.33 hours. Next. If the respective ratio of the total number of units of work done by B and C is 3:2, that is ratio of total number of units of work done by B and C is 3:2, and the average of total number of units of work done by B and C is 2500. So total work done by B and C is equal to 2500, and we are given the ratio of work done by B and work done by C. So work done by B and C ratio is given 3:2. So 3:2, one unit value will be 500. So work done by B will be 1500 and work done by C will be 1000 units. Find the difference between the total time taken by B and C to finish the work individually. Okay, so work done by B is 1500. Efficiency of B is 125. So time taken by B will be work upon efficiency, that is 1500 upon 125. Okay. Similarly, work done by C, efficiency of C, it is 100. So time taken by C will be 1000 upon 100. So that will come out to be 10 hours. 125, 150, 1500 by 125, 5 60. So that will be 12 hours. So the difference is 12 minus 10, that is 2 hours. Total unit of work was 3:2. Yes, so it is 3:2 only. Total time taken by B and C to finish the work individually. Okay, total time taken by, okay. We need to find the difference between the total time taken by to complete the total units of work done. Okay, not the individual units. That means calculating this was not required. We were asked the total time taken by them to complete this work B and C. So time taken by B would be work done by B and C upon the work taken by upon the efficiency of B. So that will be equal to 2500 upon 125. So that will be 20 hours. Similarly, time taken by C, it will be nothing but 2500 upon efficiency of C, that is 100. So that will be equal to 25 hours. So the difference is 25 minus 20, that is 5 hours. So in this question, we were not required to calculate the work done by B and C. This was not required. The efficiencies were already given to us. Okay, we were not required to calculate the individual work. Okay, we were required to calculate the time for this. So sometimes this kind of data is given to you just to confuse you, that the total work is given and the ratio is given. So normally what we do is we try to find their individual works like we did right now. So this kind of data are given to confuse you only. So no need to do this calculation. Focus on what the question is asking you. The question asks, find the difference between the total time taken by B and C to finish the work individually. And the units of work done by B and C is 2500 units. So total work was 2500. We knew the efficiency. From that we calculated the time and the difference came out to be 5 hours. Next. If A, B, C and D, they work in 1 hour cycle respectively, starting with A, find the number of hours to complete the work. Okay. So work that we have assumed. So work is nothing but 25 into 3 into 4 into 5 into 7. Okay. So now it's time that we'll have to calculate this. So 25 4s are, it says 100, 15 7s are 105. So total work will come out to be 10500 units. If they all work in 1 hour cycle starting with A. Okay. So what we'll do whenever such questions come of cyclical nature. So let us assume that when A, B, C and D, they all work. Okay. So efficiency of A plus B plus C plus D, that is nothing but the total of this, that is 200, 300 and this is 475 units are done. Okay. In 4 hours. Okay. So in 4 hours, 475 units are completed. Okay. Now we need to find the total work, that is 10500. So this is basically a cycle in which you don't need to calculate the efficiency. Okay, no need to calculate the effective efficiency. This is the total work done by them in 4 hours. So this total work done is nothing but the calculation of, like A is doing 75 units of work in 1 hour. So in 4 hours the total work done by them, A plus B plus C plus D, is 475 units. Okay. Now total work is 10500. So firstly we'll calculate the number of cycles. So number of 4 hour cycles that are required. So number of cycles required. So that will be equal to total work, that is 10500 divided by the time taken for the work done by one cycle, that is 475. So if you calculate this, you will get it again as 19. This you will get it as 420. So this will come out to be 420 by 19. So that will be again equal to 2s are 38, 40, 19, 2s are. So 22 cycles, 22 4-hour cycles will be required. Okay. So in this 22 cycles, so that means total time will be 22 into 4, that will be equal to 88 hours, and the work done will be 22 into 475. Okay. So 22 into 475, to simplify you can do it 11 into 2 into 475. So this will become 11 into 475 into 2. Again simplifying it, 500 2s are 1000, 1000 minus 50. So that will be 950. So 11 into 950, 0 as it is, 9 and 5 with 11. Again 5, 14. So this will become 10450. So this is the amount of work that has been done. So the remaining work is, work remaining is equal to total work, that is 10500 minus 10450. So the remaining work is 50 units. Okay. Now again after completion of the cycle, A will start. Now A will work with 75. A's efficiency is 75. So time taken to complete this work by A will be 50 upon 75, that is equal to 2 by 3 hours. Okay. So 2 by 3 is 0.66. So this means 88 hours plus 2 by 3. So 88.66 hours should be the answer. Okay. This was the 4-hour cycle. Number of cycles required were 22. So 22 cycles of 44 hours. So that will become 88 hours. And 88 hours, and the time required by A would be 50 by 75. Remaining was 50. Efficiency of A was 75. So 50 by 75. So this will come out to be 2 by 3, that is 0.66. So answer will be 88 plus 2 by 3, that is 66 hours. Okay. So answer is 88.66 hours. So we have wrong options over here. Answer will be 88.66 hours. Okay. So simply in such kind of caselets or in questions, only thing you need to determine is the total work by using the LCM method, and then just follow the logic that is being asked in the question. Here it was asked that they work in 1 hour cycle respectively, starting with A. That is, A, when A has worked for 1 hour, B will come, then C will come, and then D will come. And this cycle will keep on repeating. So firstly, we calculated the work done in the 4-hour cycle. So in the 4-hour cycle, the work done will be 475 units. Number of cycles required will be total work upon the work done in 1 cycle. So it will be 22 point something. That means 22 cycles will be required. So 22 cycles means time would be 22 into 4, that is 88 hours. Work done, the work that has been done is 22 into 475, that will come out to be 10450. So remaining work will be total minus the work already done in the 4 cycles, that is 50 units, the remaining work. Now this remaining work will be done by A, because A is doing 75 units in 1 hour. So time taken by A will be 50 by 75, that is 2 by 3. So answer will be 88.66 hours. Okay. So that is it that we had from the basic mathematical concepts related with time and work. These are the very basic concepts. We have tried to cover all the basic questions that were possible. We have tried to solve the caselets as well. If you have any doubt, do contact me in the faculty contacting hours that is provided at Vidhigya. Also, make sure that you have understood this concept, and I am sure once you have understood this concept, you will be able to solve any caselet, any question that is being asked in CLAT exam. There was a passage in the CLAT exam which was asked on the similar concepts that we have already discussed in the class today. So try to solve that caselet that came in the previous year and let me know whether you were able to solve it or not. So do well and keep preparing hard. Thank you.